Hi, welcome back to AT Math. Today, 9-1, Quadratic Functions. New chapter, some new ideas, but don't worry, they're going to be real easy. Trust me. You always got to trust people older than you.
I'm scared, Dad.
Do you trust me, son?
Yes.
Come on, son. Rule number one, never trust anybody.
Okay, so let's talk about quadratic functions, which we'll know as x squared. X squared is going to have a basic shape. It's going to look pretty much like this. You're going to have it slope upwards like this here, and have a reverse slope of the same thing. In fact, it's basically going to be mirrored between the two. So you're going to have a point here, and it's going to be a reflection from one side to the other. And that's the general idea of a quadratic function. It's going to be a reflection. It's also going to be a horseshoe that goes like this. Starts kind of slow and wide and gets bigger and faster and slimmer on the way up. It never actually becomes parallel like a U, but it pretty much gets on this way. Before long, it looks almost like a U. So they look like this, in fact. And this is x squared. The only difference is the negative x squared is simply flipped upside down. So instead of this, it's this. That's the basic idea. Now, to check out a quadratic function in a table, let's take a look at y equals x squared. Now, to save a little time, I just put 0, 1, 2, 3, 4, and I went ahead and put the different numbers in here. Now, how do you get that? Well, 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, and 4 squared is 16. Now, let's notice that there's constant change in the x value. From 0 to 1, 1 to 2, 2 to 3, 3 to 4. I'm increasing by 1 every time. However, when you check the y value, notice how I go from 0 to 1, and that's okay. But then I go from 1 to 4, 4 to 9, and 9 to 16. And notice that my y value is not constant. I've increased by 1, increased by 3, increased by 5, increased by 7. Now that tells me that it's not a linear function because it's doing this. As I'm going over 1, I'm going up 1, over 1, up 3, over 1, up 5, over 1, up 7. So it's not a consistent linear pattern, but there is a pattern to this. What you have is, yes, these are all different, but let's notice the increase in each one. There is a trend. Yeah, 1, 3, 5, and 7, which is called the first difference, which is how you check for a straight line or linear equation. But if we check the difference between 1, 3, 5, and 7, you will notice that we're increasing by 2 every time. Now that's called the second difference, and the second difference is x squared. So actually we are increasing by 2 every time, so we do see an increase, so that's okay. Notice the second difference is the same. Is it the same on the second tier? It is the same on the second tier because the exponent is 2, thus quadratic. So let's see if this table is quadratic. So you have x is negative 4, negative 2, 0, 2, and 4, and y is 8, 2, 0, 2, and 8. So I want you to determine, or we can work on it together, whether or not this is a quadratic equation based on the table. Let's take a look. Measuring the x values, you notice that they increase by 2 every time. Now whether it's by 1, 2, 4, or a million makes no difference. I simply wanted an even increase every time. The number that it was doesn't matter. Now notice the y value, however, I go from 8 to 2, which is negative 6, 2 to 0, which is negative 2, 0 to 2, which is 2, 2 to 8 is 6, clearly not the same. So it's not first tier, which means it's not a straight line. But if I look closer between negative 6 and negative 2, 2 and positive 2, negative 2 and positive 2, and 2 and 6, I will notice that they increase by 4 every time. So as a second tier, it does work. Therefore, it is a parabola. Or you can simply graph it. Plug these numbers in. Notice you have your basic horseshoe. The program I use cannot give me a perfect parabola, but it gets it pretty close. So see the x squared, so it's quadratic. Let's take a short break. Okay, now let's get working on graphing. Y equals 2x squared. Let's make a table. Y equals 2x squared. You can use any numbers you want, but I would suggest negative 2, negative 1, 0, 1, and 2. Again, I call them the easiest numbers in the world. So I'll go ahead and plug these numbers in for x value and take negative 2 times itself, then times 2, Negative 1 times itself times 2. 0 times itself times 2. And so on. And I'll get 82028. When I put them in there, notice as I plug them in that I get a parabola. Again, this should bend a little sooner like this, but my program won't quite allow it. But notice how it is a quadratic formula. So it's good to go. Now you try. Y equals negative 2x squared. Here's a hint. Instead of going up, it's going to go down. Go ahead and try. Let's see how you did. I plugged in the easiest numbers in the world, negative 2 to positive 2. Now, why am I getting negative values? Because negative 2 squared makes positive 4. Then 4 times negative 2 makes negative 8. Negative 1 squared makes 1. 1 times negative 2 is negative 2. 0 squared is 0. 0 times negative 2 is 0. And so on. And notice how it forms a parabola. I will try to freehand it with this. But again, it's not going to be perfect. But that's the general shape. And imagine that it's a perfect reflection, you would have it. And negative 2x squared plus 2y equals 8. Step 1, let's make it y equals mx plus b. So in order to make it y equals mx plus b, I have to get rid of anything that's not y. Negative 2x squared therefore has to go. What's the opposite? Minus 2x squared? Well, add 2x squared. Add 2x squared to one side, you got to add it to the other. So I'm going to add it here and add it here. This goes away, leaving just 2y. This I'm going to change and put 2x squared in front plus 8, and all you have to do now, instead of times 2, is divide 2 here and divide these 2 by 2 as well. Divide everything by 2, and you're going to get y, and then this goes away, x squared, 8 divided by 2 is 4, so y equals x squared plus 4. Let's just graph using negative 2 through positive 2. And again, negative 2 squared makes 4. 4 plus 4 is 8. And negative 1 squared is 1. 1 plus 4 is 5, etc. Notice how it still forms a parabola. Granted, it's 4 up from 0, 0, but it's still that basic shape. So you're good to go. Let's take this again. Y equals 2x squared. We're going to go ahead and plug it in. Negative 2 squared is 4, times 2 is 8. Negative 1 squared is 1, times 2 is 2. 0 times anything is 0, times 2 is 0. 1 squared is 1. 1 times 2 is 2. 2 squared is 4. 4 times 2 is 8. So again, basic shape. Yeah, it's a little thinner, but it's still a basic parabola. So you're in good shape there. Anytime the coefficient is a positive, the parabola opens up. In other words, because 2 is a positive, it's going to open upwards. And the negative, I'll just breeze through it. Y equals negative 2x squared. So instead of like this, it's like this. It goes down, kind of like a thin mustache, although with handlebars, I guess. So y equals negative 2x squared. We're going to plug all the numbers in. Negative 2 will get you negative 8. Why? Because negative 2 squared is positive 4, and 4 times negative 2 is negative 8. Negative 1 squared is 1. 1 times negative 2 is negative 2, etc. You form your parabola, but it's going down. It's a negative parabola. Since that is still a parabola, but it is upside down, so it opens downwards. Well, anytime the coefficient is a negative, then the parabola opens down. I said it, so it's good. Quick break.
What's that, a bear?
And back. Now, this again, y equals 2x squared. So, now we know it opens upwards, but now we want to see the maximum minimum. Now, when I mean maximum minimum in this case, we're just going to talk about the y value, okay? We'll talk about the x value. We talked a little about it before. We'll get back to it. Right now, I just want to know what's the maximum and minimum of the y based on possible x's I can use. Well, 2x squared, take a look here. This is the general shape. Notice that the smallest amount it can get to is 0. It can't go any lower than 0. And why, might you ask? Because any number I square will turn positive, and so the lowest I can do is 0 itself. Anything above that, whether it's positive or negative, will square and become bigger and will times by 2. So my minimum here is 0. Now the maximum, it can go as high as it wants. There's really no end to the maximum, so the y maximum is infinite, which I'll explain. We see the highest and lowest point we talked about. The lowest point of the parabola is 0 because of the way it's set up, so the minimum is 0. Highest or lowest point is called the vertex. So that this point at 0, 0 for this particular equation, that is the bottom, and therefore that is the vertex, or the middle point. Notice that if I draw this here, you're going to notice that if I draw this down, it splits it right in two. So this spot that makes the split is called the vertex, and it's basically the dividing line between both reflections. Since the x value can keep going forever, the parabola will go up forever. The parabola has no maximum. In other words, y can be as high as it wants, provided the x is there for it, but there is a minimum y value at 0. It cannot go negative for this particular equation. You try y equals negative 2x squared. I want you to go ahead and graph it, find the vertex, or that middle spot where it splits it, and give me the max or min. Here's a hint. It's going to go downwards. So you're going to have a max, but you're not going to have a minimum. Go ahead. Let's see how you did. Y equals negative 2x squared. I went ahead and plugged in some numbers. The highest point in this case is the 0, because any number I take, the square will become positive, but anything times negative 2 will become a negative again. So the highest point I can use is 0, because 0 times 0 is 0, and anything times 0 is 0, so the highest point is 0. Everything goes down from there. So my high point is y equals 0. So at 0, 0. So when x is 0, y is 0. That's the top point. That's the vertex. The middle point of the x is x equals 0. So we have 0, 0, and at the maximum 0. There is no minimum. So the minimum, you can write a couple different ways. I'm going to say minimum is negative infinity. And there you have it. You try. Find the max and min, the vertex, just by what you see. So basically take a look at it, find the low point, make that the min. Is there a max? See what you can do. Well, for right here, this is the low spot. So at 3, negative 3, that's the vertex. That's the part that divides it in half. The bottom point, by the way, is the same spot. The minimum is going to be at negative 3. It's negative because it's the low point for the y value. And there you have that. Now we got the min and max. Now we have to, oh, and there is no maximum. Maximum is infinite because it goes up forever. Now we find the range, which I think actually I just covered. The minimum is negative 3, so that's the range for the minimum. And since it opens up, you have to start with the maximum and make it all the way to the low point and work up like that. So simply put, that's your min. There is no max. So y is greater or equal to negative 3. That's the range, meaning yeah, negative 3 can be that low or higher, and there is nothing else than that. So vertex 3, negative 3, minimum negative 3, range y is greater or equal to negative 3. Thank you very much. We'll do some of these in class. You know, keep up with it day to day. We're going to be fine.
It's coming back. Embarrassing.